So hi, my name is Ilan Rabinovitch. I'm the director of technical community at Datadog. I'll be joining you today for the next 45 minutes or so, talking about monitoring and scaling Redis in our environments. A little bit of background on myself. Big fan of open source software, including Redis. I've been running around evangelizing or advocating for open source for about 15 years now, about as soon as I could drive to an actual Linux users group of some sort to talk to people about it, I was there. Worked at various large-scale web operations, places like Edmunds.com and Uyala, which is where I first encountered Redis. That guy in the front row tortured me with it on my first day. Sorry to point you out there, Daryl. Monitoring and metrics, been monitoring in some way or another for a living for pretty much all of my professional career, and then my hobby tends to be running community-focused events. So I organize Scale down in LA. I help plan the Texas Linux Fest with some friends out in Austin. Things like DevOps Days, LA and Silicon Valley involved with all of those. So you've likely run into me at some event or another, and I hope to see you at one of those that I listed. So. But our plan for the day. So we'll do a quick overview of what Datadog is and kind of give you a sense of the scale that we're talking about, what we do as a company, and give you a sense of where Redis fits into that picture. We'll do a quick tour of what we call Monitoring 101. I'll do the very short, too long don't read version. There's you can find our longer version online, but give you a sense of what we mean by metrics and how you can categorize and succeed with them in your environment. And then we'll dive into some examples of how we're using Redis in our environment, and some of the key metrics and examples of how to collect that data. So that overview of Datadog that I promised. How many folks have heard about Datadog in the audience? I mean, beyond mine. Cool, that's pretty much everybody. Fantastic. How many of you guys are using us? Awesome. So what we are is infrastructure and app monitoring as a service. We collect metrics from all of your applications, all of your cloud service providers, and more. We have an open source agent written in Python that runs on your host, collects locally, collects metrics, sends that up to our platform. All kinds of time series data, so that's both metrics and events, and we'll go into a little bit more of what that means in a second. We're at this point processing nearly 1 trillion data points per day. We use Redis everywhere. It's a little bit of an addiction. So if you're looking for a place to work with Redis, we're hiring. Find me afterwards. I'd be happy to chat with you about our roles for SREs or software developers or pretty much anything else. We're growing quite a bit. So I said monitoring everything. That means things like operating systems, all the different metrics coming from the kernel or user space or proc, what have you on your OS. Other monitoring systems, you see things like New Relic and PagerDuty and Nagios on there. I mean, we want to collect all of the metrics, help you bring it into a single place, help you do things like intelligent dashboarding and alerting with it. So that, again, that's going to be queues, cloud providers, containers, web servers, and the like. And so I'm here at RedisConf today, or RedisConf today, and you might ask, like, why are we excited about Redis? I know I said we're a little addicted to it, but also our customers seem to be as well. We did a study back in October of Docker usage patterns and how folks across our customer base had been adopting Docker. Being a SaaS-based monitoring provider, you guys are all sending us your metrics, and in an anonymous way, it's fairly easy for us to see what technologies are popular in the world at any given time. And so in this study, one of the things that we found was that Redis was in the top 5 applications that we were seeing people deploy in Docker containers. Yes, I realize Ubuntu's there, and there's some other things that are maybe not necessarily technologies that you're deploying in the container, but in terms of apps that people were running, I mean, Redis was in the top 3. So we're clearly seeing a lot of interest in Redis from our customers. We integrate with it and pull well over 50 metrics from Redis, just from Redis itself, and help you monitor and alert on that. Within our own environment, though, again, we're using Redis quite a bit. At a high level, we're doing quite a bit of queuing. We do some caching with it. A little bit of session state, although I believe that's in the process of transitioning out. So that's, again, the sort of the preamble of what we do and why this is interesting. So monitoring 101. We'll take you through a quick tour of this class. Why do we monitor? Well, you wouldn't drive down the highway with your headlights off or the wipers off as it's raining. You want to know when things are happening in your environment. You want to be able to tell your boss why something went down. You want to be able to respond. Because regardless of what we do, we're going to how amazing our systems are, we're going to have some sort of incident. We want to be able to measure where we're going. You really don't want to be this guy on your Twitter on your status page feed. I don't know why this happened. We'll just try to roll the last thing back. I don't know why this happened. We'll add monitoring next time. How many folks have had a postmortem? I hope you guys are all doing postmortems. I won't ask you to raise your hands because I'm pretty sure everybody here will raise them. But when you have incidents and you do a postmortem, how many times have you had an action item that basically says, I don't know why this happened. I can't tell you if it'll happen again. But if it does, this time I promise I have monitoring for it. Nobody wants to raise their hand. They're all embarrassed. We're going to have these types of crashes. We're going to have something splatter across our windshield. We want to have tools available to us to have visibility into our environments, into our applications. So that might be monitoring of our services, but it's also monitoring of how our teams are doing. So this is for example, some dashboards showing you how often a given service has alerted you, so that you know where to put your attention as an engineering team on improving your response times or improving your stability, or really just avoiding the pager fatigue that we all hate. If you're getting, what is that, something like 259 alerts or whatever that is a week, you're probably not sleeping much. I've seen teams that they say they check every one of the 10,000 alerts they've gotten in a given week. I guarantee you you're not. You're not sleeping if you're doing that, in which case, even if you're seeing them, what are you doing with them? So those are metrics as well. So remember that collecting all this data is cheap when you have it, and it's really expensive when you don't, right? Going back, as I said, when you have a postmortem, trying to figure out why these things occurred, pretty tough if in retrospect. So you want to try to collect all the things, instrument them all. That might be custom metrics from your applications. That might be operating system metrics or technology metrics, things from around your environment, but everything. So what does that mean? Well, complexity sort of increases with the number of things that we have to measure and the velocity at which they change. And so what are we measuring? Well, and this is sort of on average is what we're seeing across folks that we interact with. They've got about, on a given instance, let's say lots of folks tend to be in Amazon these days. You probably get about 10 metrics that you're collecting from CloudWatch. Maybe another 100 metrics from the operating system in the case of Linux, another 50 metrics or so from your applications. In this case, again, Redis is about 50 metrics that we're able to capture from there. Now, we just talked about containers and how popular they were a second ago from the study that I mentioned. So we're all containerizing these things, and what we're finding is that the density at this point is about 4 containers per physical machine or per virtual host on average. And so we get to multiply that out. We had 100 instances before, maybe. Now we got 400 containers. That becomes about 640 metrics per host. Keep going down this combinatorial math, and you end up with about 64,000 metrics. Now, hopefully, you're collecting these pretty regularly because things are changing all the time, and so we're not talking about RRDs where we're looking at chunked data from over the course of averages over hours or minutes or days. We're keeping this at full granularity at second level or at least single to double-digit second level data. This adds up quite quickly, so it ends up being a little bit of metric overload. So we got that. We got how much we're changing. We're talking about now the velocity of change. Well, if you're in Amazon, you're likely doing some amount of auto-scaling. If you're using containers, you're probably doing some sort of scheduling there as well. And what we're finding is that VMs these days are lasting about, again, this is the median, are lasting about 12 days. And the containers are about a quarter of that at around 3 days. So that's a lot of change. Things that, we used to be able to name our server. I know the pets versus cattle sort of thing is becoming a little bit of a cliche to mention in talks. But it's true. I mean, you used to be able to name all your servers after the planets in the solar system. Now they're changing hourly, if not daily. You can't do that anymore. So again, these things are the half-life of our instances in our containers is sort of decreasing quite quickly. The velocity of this change is growing. So those we talked about those two aspects, and so you guys get to miss out on the seizure. I don't know what happened to this guy, but the idea is you don't want to be there. You go. You don't want to sort of be this guy, right? Like you sort of overload on these metrics, not knowing where to go next. So we need a little bit of a system to track our metrics and how do we interact with them. Want to maybe find the signal in the noise. And so we came up with this Monitoring 101 guide, as I mentioned at the start. You can read the longer version online. The URL's there. It'll be in the slides afterwards. You don't have to jot it down. But our goal is to help you figure out what to alert on and what matters to you. So the way we do that is what we recommend folks do is break your metrics down into 3 categories. Work metrics, resource metrics, and events. So let's talk a little bit about what those mean. So if you imagine your application as a factory at any tier in your environment, the work metrics are the things that you're outputting. So my name's Ilan. People seem to, every time I show up somewhere they don't know me, they say, you're not Musk, right? So we'll talk about cars. Let's pretend we have a car factory. Work metrics are the things coming off that assembly line. Those are those cars. It's the number of cars that show up at the assembly line that we can sell, the ones that aren't lemons, the ones that aren't missing tires, the ones that have their windshields on right, the ones we can turn into money. In the case of our web application, that's probably API calls. In the case of our database, maybe it's gets versus sets or inserts versus deletes, things like that. Performance being the sort of the throughput of what we're able to the throughput of what we're able to output from our assembly line, and then of course performance being how much work it takes to generate one of those. So I think I skipped this, the resources. So resources are all the things that go into that to making those widgets in the factory. The tires that go on the car, the windshields, the wipers, all the pieces that we need to make that happen. Utilization is how much of that is available to do more work if we needed to spin up. Maybe I went on stage and announced a car we don't have yet. I'm going to make you guys all make a bunch of cars really quick right now. We need to know how much slack we have in our pipeline here. I love using tweets for examples here, but as you're trying to think about what's important to you, really it's the work metrics. Nobody ever calls you and says the CPU is kind of high right now, I want my money back. What they call you and they say the API is too slow, the API is not responding, the website is down. No CEO is going to wake up in the middle of the night and say, I think the CPU is a little high, right? So the questions that you want to ask are more about those business cases and about the symptoms that your users are experiencing. The final category I mentioned was events. Now, events are things that you've done to your pipeline, whether it's an announcement of a new thing that you're selling, a change in the formula, a change in the assembly line, or in the case of us, code. We're pushing code and configuration to production all the time. So these are the things that provide us with context about why metrics dipped or spiked in one way or another. So again, some quick examples. In the case of a web application, this is fairly generic, but requests per second would be that throughput that we talked about. Dropped connections might be that error rate. 5xx or 4xx, again, are the errors, 2xx are successes, things like that. Resource metrics are going to be things like disk, bandwidth, memory, CPU, all the things that go into making our API calls happen. And events, again, we talked about things like cache purges or code changes, all the different things that you might do to your environment, changes you might make, whether planned or unplanned, Super Bowl ads you might buy for your amazing mobile app that might increase traffic or decrease performance. So when do we page folks? When do we let a sleeping engineer lie? What we encourage folks to do is page on symptoms. These are, again, the work metrics. And then use the resource metrics and the events to diagnose why something happened and try to work your way backwards from that. Now, that's a rule of thumb. If you're a database and your disk is full and people can't write more data to your database, that's an outage. Page before that happens, please. Don't come back to me later and complain that I told you not to page on resource metrics. There are situations you should apply this rule to your environment as appropriate. But the short story here is you can use this framework to dive all the way down your stack. Everything in your stack has a work metric, whether it's the database at the end or the front end application the application at the front. Each one of these has a thing that they produce. We'll talk a little bit about what some of these are in the world of Redis in a minute. So cool. The life of a metric. We'll talk a little bit about what happens. How do these things get to us? Right? We started with all these different technologies that we wanted to monitor. And we want to turn them into something like this. Dashboards, alerts, things that, I know we don't want to turn them into alerts, but alerts are what we do at Datadog, and that's what we want to help you figure out when things are anomalous in your environment. So what do we mean by metrics? Well, again, that should say trillions of data points per day. These are time series data, things like timestamps, and these tend to be a mix of timestamps and then a value. Millions of events per day. These are text things. These are again the things that are changing in your environment. Metadata being the things that are all the context around those metrics. We store those at 1 second resolution, and we store them for 13 months. So you can do year-over-year seasonality. As you can imagine, that adds up very quickly. We were talking about 64,000 metrics, give or take a second in that 100 instance environment. Well, in your imagine we do that across thousands of customers. That adds up pretty quickly. So I mentioned events earlier. When I say events, that this type of stuff is it's really this sort of like think of it as like the event feed for your environment, things that are changing all the time. All of this is stored primarily in Elasticsearch. So we're going to skip over the majority of this for the talk today, just giving you some context of what we do and what our environment looks like. And events, events are nice. You get to overlay them on graphs. So I don't know how visible this is from the back. The pink wasn't probably the greatest choice. But these are lines that show deployments or changes in an environment over I/O weight, for example. How are our releases making, and the nice thing about being able to overlay events in that way is you can try to find why something occurred. Did it happen because of a deployment? Did it happen because of something that happened in our environment? Maybe every time a chef run happens, that's when the availability of something goes down, whatever it might be. So again, a metric is born. We got these open source Python agents running all over the world. They're collecting metrics from your various applications. We have SDKs and libraries accepting metrics via statsd or what we call dog-statsd. It's a slight variation on statsd itself. These are all being pushed up to our RESTful APIs. Again, there's many more boxes on our diagrams, I promise, but this is sort of at a high level what that flow looks like. So the last place that we're pulling things from is, of course, SaaS integration. So these are things like those cloud. Those are integrations that we're hosting on our end, where we're calling up Amazon, we're calling up Google, we're calling up New Relic or whatever it might be, and pulling those metrics into our environment. That's going directly into our backend systems there via crawlers that we run. So when I say metric, what does that look like? Well, this is more or less the payload body of a metric that comes to us. It's a little piece of JSON. Basically, it's you'll have the metric name, the number of points. This could be one or more data points there. So a timestamp and a value. The type. So maybe it's a gauge or a counter or something to that effect. The host name that it came from and a bunch of tags. So what do I mean by what do these different pieces mean? Well, the metric name is the what we're collecting, of course. The metric value being how much. So is it 1% CPU or 100% CPU? The timestamp being when. Generally these are time in milliseconds, so epoch time. And the tags are where. So tags let you slice and dice your data in interesting ways and across any dimension. And this is how we provide a lot of context around where these metrics come from. Let you do the queries that you want to do. So. And where these tags come from, that's all the way down. It's starting in like these tags are things that are coming from your Amazon instances, from your applications, custom tags that you might set yourself in your configuration files, labels from Docker or Kubernetes or one of the many other resource scheduling solutions that are out there. And so what you can see here is that there's tags can be everything from the instance size to what's running on the instance to where that instance is located, whether it's US East 1A or 1B or US West or what have you. And so the idea is you can use this to kind of slice and dice across your environment and figure out what a metric looks like across a certain tier. And you can ask questions like this, rather than saying, is my web server up? You want to ask, is a particular web server or host up, or is the memory usage on it high? What does it look like across my entire cluster based on these things that are underlined, which are, of course, tags? What does my response time look like? Let me know when my response time is taking more than 5 cents to process and respond. 5 seconds, sorry. So these are more intelligent questions than is the port up or is CPU high, right? Things that you can sort of get across your environment. So we'll fill this in really quick. This is kind of an example of what a metric submission might look like. So again, we talked about system CPU, and we talked, example hosts and what have you. So our intake APIs are, of course, the next step. These things are coming into us, and so this is a constant stream of data. We don't really have we don't really have peaks and valleys. Your servers are running all of the time. We're collecting metrics all of the time, and every time you spin up more servers, we get more metrics. So we don't have sort of the normal peaks and valleys that you might see with the time of the day. Your servers are still sending metrics whether or not they have traffic on them. We have fairly low latency requirements. Here I say 30 to 60 seconds is sort of the high end. It's usually far lower than that. So we have to pick those metrics up, process them, and turn them into something useful to you in a very short period of time. And that needs to go to dozens of different systems. So of course, this is a very high level of flow of what that looks like. But metrics come in. We have a an intake queue that will accept them. It's doing very rudimentary work on those metrics. Basically, maybe some API key validation, validating that the timestamps are correct, that the data follows the correct format, but not much more than that. It's really doing the minimal work possible. And then it drops it into queues that get picked on Kafka that get picked up by all of the different, much like all of you, we're going on the microservices craze, everything's a different system. There's lots of different guys that want to pick these things up and pass the data between them. But our main goal, or the most important part of this part of our application, is to not drop any metrics on the floor. You sent us metrics. You want to know what their values were. You want to know what they were over time. We need to make sure that they always succeed and that they're always ready for you to query when you need them. So Kafka and all of these other systems that are behind the intake queue, they're fairly complex. They're distributed systems, and as much as stability is part of their goal and part of what they want to do, the reality is they're complex and things fail and bad things happen, and we want to make sure that even in those situations, we're not dropping things on the floor. So the first Redis use case that we have is queuing. As these metrics come in, they get queued up in a very simple Redis queue, and then slowly popped off onto Kafka by workers that are then picked up by consumers down the line. And then again, all of our backend systems and processes. So if any of those backend systems were down for some reason, we have a nice period of time where we're not losing these metrics. So why Redis? Well, it's easy to scale both vertically and horizontally. We use Twem proxy to sort of load balance the metrics across a large cluster of these Redis hosts. We need more capacity. We can either just spin up bigger hosts or spin up more hosts. It's fairly straightforward. The simple push-pop semantics make it really easy for us to get things in and out of the queue. There's not a lot of complexity there. And so it's fairly straightforward to interact with from both our operations folks and our developers. Love it. There's not a lot of we're not running repairs across a crazy Cassandra cluster. We're not trying to figure out how to rebalance the ring. It's add and remove. It's pretty straightforward. So what do the metrics for something like this look like? Well, queue depth, of course, right? We talked about the latency requirements. We want to make sure that as metrics show up in our Redis queues, that they're coming out very quickly on the other end. They're not spending a lot of time sitting in the queue there. And that's something that we can pick up both from the metric itself, based on the times that are in them, but also in terms of the number of keys that we have and the rate at which the number of keys in Redis is growing. Message latency is a similar concept, but again, this is more from within our own applications. Command latency, Redis just returns this from the info command. How long did it take a command to run? What you'll find is in most of these metrics, what we do is we're collecting these on both ends, both within our applications and emitting them to Datadog, of course, but also collecting them from Redis itself. And then reads versus writes per second. Again, this is another way to look at, are we reading at the same rates that we're writing? If that were to go inverse, I know this graph looks almost like it's just one graph. There's actually another slightly higher line on top of that. But the idea is, we want the reads and writes to basically match up, so that we're, for everything that we're pushing in, we're immediately, pulling it back out. Redis commands per second is, we talked about earlier, is another metric that we want to look at. These are the gets and sets combined, and they kind of tell us how much work an individual Redis node is doing. On the resource side, these are things like network utilization. We find network performance is probably the least quantifiable metric in the cloud world. People tell you that your host has 10 gigs of memory on it, or it has a disk of a certain size. Places like Amazon, the best they're willing to tell you is that it will have high network I/O or low network I/O or medium, and you can try to quantify it yourself, but it tends to be a little bit variable. Are you in VPC? Are you in Classic? All these different rules apply, and so you have to try to figure that one out. So you want to keep a close eye on network utilization. Again, if you can't get metrics into your queue or out of your queue, that's a pretty concerning situation. Used memory, of course. If all those backend systems we talked about are down and we've filled up all of our queues very quickly, we're in that problematic scenario where we're dropping metrics on the floor. Similar story around disk I/O and disk space. In this case, we're storing all of these metrics persistent to disk as well. Again, if we can't push them out, we want to make sure that we're keeping a copy of them on disk. Connected clients is a key metric as well. You're probably setting max clients within your Redis confs. You want to make sure that connected clients is somewhere beneath that and not hitting that. And that's another place where you can kind of sense, do you have enough utilization do you have too much utilization? Do you need to grow or shrink the cluster? And then, of course, key space showing you the number of keys that you're storing there. And if that's growing over time, that's problematic. So the second half of this view, right? We talked a little bit about we've talked about the intake side of it and where queuing fits in there. But what about the output side? We do lots of interesting things with your metrics. We do things like anomaly detection. We do things like alerting. We do things like dashboarding. And so you can see there's a fairly complex set of mishmash of technologies in there that fit in there. And depending on the time slice that you're looking at, that might be Redis, or it might be S3, or it might be Postgres, or we even have written our own proprietary data stores in-house, and I'm happy to talk with folks about that one later. It's not Redis, so it's not really germane to this talk. But as you can tell, it's lots of different systems there. Between all of those systems, we talked about Elasticsearch earlier, right? We're using that for events. Between all of those different systems, as these guys are interacting, latency is important to us, both in terms of the response times on those graphs. We want to be able to draw hundreds of points on a page and return those to you quickly. You're likely staring at a dashboard that's refreshing every couple seconds. Those are the fairly similar API calls to us. So we want to be able to cache those as well. And so between almost every tier and almost every connection somewhere within Datadog, there is probably a Redis cache there to help make your life, to help make you happy in terms of response times. So as we're doing that, on the way, again, so things are coming in on the input. On the output, they're coming out as refined data. These are graphs, alerts. You might be interacting with them or APIs or pulling them up on dashboards. So again, as I mentioned, the second use case here would be caching. These are metric queries. Like I said earlier, we're a bit of caching addicts. Our goal is to reduce the latency and response times to our customers, but also between the systems, and ideally reduce the load on our backend storage tiers. So our first attempt at something like this, fairly straightforward. I'm sure you guys have done it hundreds of times before, but it's sort of a cache-aside setup with Redis, right? We might be talking to something like Postgres or Cassandra or some web service on the back end, and we're going to store the results of those queries in our Redis cache. Most of our applications are Python, some Go. And so they'll just have a local Redis instance sitting right there. Fairly low latency to get stuff from there if you already have it in the cache. If you don't, you go and read it from the database or from the data store and move on. LRU works great because you're going to pop out the things that that are least used, and over time things will churn. In these situations, we're generally disabling persistence to disk. We don't really care about we don't really care about this caching data disappearing. We can always query it again from a data store, and it's great. Effectively, we don't want swap. But quickly, we start to hit the limits of cache efficiency there. If you're not doing something like load balancing your traffic to, based on API routes or keys or what have you to the same host, you're likely going to be, if you're not doing that sharding at your load balancing or the layer 7 load balancing layer, you're likely going to be churning through those keys fairly quickly as you're doing LRU. And so we start to be in a situation where we're trying to figure out, do we scale hosts bigger or do we scale hosts horizontally and reduce our cache efficiency, but maybe gain some availability or some other capacity elsewhere in the application. So the next step in our environment was to, what we started to do is create a library called Dogpound. Our application names tend to be named after wire characters for some reason. We're all very excited about the wire, but in this case, we chose something dog themed. And so the goal here was that we needed to scale our caching beyond what a single instance could offer, right? We wanted to get higher cache efficiencies. In a lot of cases, the caches needed to store more keys than a single instance could hold. We want to be able to spread that around. We found that pretty much everywhere in our environment, there was some amount of interaction with caches, whether it be in memory or in Redis or some sort of sharded Redis environment or even a tiered configuration. We'll go into what those look like in a second. And so we wanted to standardize our interactions with those a little bit, so we created some libraries to go around this. And of course, we wanted HA for our cluster. While we don't care about an individual node failing, if all of the nodes in a cluster fail for some reason, or if there's only one master node that you're talking to, and all of a sudden all the requests are hitting the backend data store, that's a bit of a herd or avalanche of requests that might be the thing that actually takes us down, rather than the Redis instances being down, just things, being able to stomach all that traffic. So we want to avoid losing that entire cache at once. So I mean, if that wasn't the case, maybe something like a master-slave environment might work, where we just sort of fail over between it, or maybe using something like Zookeeper Redis or Sentinel or what have you. But we wanted to make sure that we had ways to shard that. So what we ended up doing was building this using Python's hashring. Remember, I talked about how most of our applications are written in Python. Hashring is a Python library that offers you the ability to do consistent hashing. And so what this allowed us to do is kind of increase our cache efficiency. We're ensuring that we're making that similar requests always go to the same Redis hosts. Redis hosts are generally not storing more copies of each other's data. Otherwise, we could look at, again, we're not really caring about durability of individual pieces of data in this particular case. What we care about is durability of the cluster as a whole. Otherwise, we might have looked at something like Cassandra that has this sharding built in. But again, this level of the availability concerns that we had were a little bit different there. And we like things that are simple, as I mentioned earlier. We use Redis everywhere, so it's pretty straightforward to do that. In this scenario, you can see losing a single node is really just 1 over n data lost. And so if 1 over n data is ever too much for you, you just add another node and n becomes bigger. So why not twem proxy? Again, we were using it at the front there. We've sort of gotten big on this idea of hot configs and feature flags. We like to be able to push things out quickly without having to restart or take down applications or do deployments. So we use console everywhere. My colleague Darren Froese gave an amazing talk at SRECon. You should look it up online about how we scale that. That's a whole different hour-long talk in and of itself. But we're quite happy with that. And in twem proxy, what we found is that we couldn't easily reload or change these configurations on the fly. And so we started looking at, we ended up building this within our own application and again, relying on console for that. So the next sort of configuration that we've done is a bit of a tiered cache. This is where we might combine the properties of the two caching mechanisms that we talked about earlier. If you have a situation where you are getting fairly high cache hit ratios on an individual node, but want to be able to, again, scale that out further, it's a similar story. Run that cache. We'll run a Redis node on the individual host with that application, one Redis per worker, and then again read aside cache or cache aside setup where we're going out to the data store again, often Postgres or Cassandra or some other web service, storing the hits both in the shared cache as well as in the local cache. This gives us further cache efficiencies on the individual host, very low latency requests. Losing a single node at any point is still not catastrophic, and we get the ability to do a little bit of tiering here. So what are the work metrics that we look at in a caching scenario? Well, of course, cache hit to miss ratio. We all know these from our HTTP work, right? If our cache hits are low, the Redis or whatever the cache might be is not actually particularly useful to us. It's just another layer in our environment getting in the way. Commands per second, again, similar to what we might have seen in a queue. Again, we want to make sure see how much work a given node is doing. The number of keys stored per host is really important. Again, we talked about that one, how if you lose an individual node out of n nodes, that's 1/nth of the data that you might lose in your environment. So you want to keep track of how much that's going to be, and if you're in a situation where you're going to run out of capacity in this cluster and start purging things fairly quickly, or if you're in a situation where losing one node might cause more downstream queries than you would like. And then, of course, request latency. If it's more latent to request things from the Redis cache than just to request it from the database, that's not a good situation either. So resource metrics, these are fairly similar to the queuing story we talked about earlier, but with a couple key differences. Evicted keys is a key one to pay, pun there, is a good one to pay attention to. If you're seeing the number of evicted keys to be quite high, that's likely going to be why your cache hit ratios are not where you would like them to be, and you can start to look at that and figure out how that ties into other resources like memory. Network utilization is, of course, a problem, especially if you're you don't want to be doing operations on these hosts that might be taking up as much traffic as, say, your application is. And then, of course, connected clients, right? You want to make sure that you're growing this quickly enough that you can stomach connections from all of your servers. But I'd say evictions and memory are likely the two that you want to spend the most time on here. So as we're going through this, some examples of types of graph that we might create. This is one that shows us memory on a particular memory by host on a particular Redis cluster. What we tend to find is that you see these fairly flat line patterns in terms of memory usage. In a well-used cache, what's going to happen is the Redis is going to begin storing as many keys as the memory will allow it to on the host based on what you've configured it for. And then what you'll see is once that memory hits sort of full consumption, that's when you start to see the LRU algorithm kick in. You'll start punting out keys. But it's going to happen on a fairly consistent basis. You'll be able to see a fairly flat line there. Again, these are a lot of the types of metrics we were talking about earlier, number of clients per host, hit rates. Again, that's a pretty efficient cluster. That's 100%. I don't know what cluster that is, but we're clearly not having a lot of churn there. And the idea is you want to be able to look for these changes across your cluster. I really love these types of things like these heat maps that let you see. These are 3D graphs where you get to see the y-axis is the value, the x-axis is time, and the darkness is how many hosts you have there. So you can see sort of this red tier here at about 1 gigabyte is sort of the most frequent use case that we're seeing in this cluster. And then, events. We talked about events earlier. I haven't really touched about events at all in this particular environment, but one of the things that we see most frequently will be adding or removing of nodes. That's an event that might impact you in one way or another, whether it be because your hash has now changed and so your efficiencies are going to change, or because a node is down and now you're querying that backend tier. Any incidents in your environment will, of course, also impact the latency and the responses here. Most frequently, things like code deploys or config changes might change the cardinality of the number of objects that we're storing. And so we may be churning through more within our Redis clusters or not. And so these are things to keep an eye on and overlay on our graphs as we were talking about earlier. And on that note, I think I'm within 5 minutes of time. So I hope to keep you out of the doghouse and chat with you guys about monitoring, whether it be here or afterwards at the reception. But thank you very much for coming out. I got Datadog stickers and things up here, and I'd love to chat with you about how you're monitoring Redis and how you're using it in your environments. So thanks.